Hello everyone, this is lecture 2 of Basic Programming and Modeling. We are now reaching the second part of lecture 2, which is about data in a computer. So, when we talk about data in computing, it all comes down to bits. So, what is a bit? A bit basically is defined by a logical state. It's either 0 or 1. So a bit has two states. So if you have one bit, this one bit can vary between 0 and 1. One bit, two states. If you have two bits, then you can generate four patterns. So the first pattern would be 0 and 0. The second pattern is 0, 1. The third pattern is 1, 0. And the last pattern, number 4, is 1 and 1. With 2 bits, you have 4 states. 1, 2, 3, 4. If you have 3 bits, suddenly you have 8 possible states. You can read them all here. These are 8 states. So each time you add a bit, you double the number of possible states. 1 bit, 2 states. 2 bits, 4 states. 3 bits, 8 states. So the number of patterns, or the number of states, are proportional to 2 to the power number of bits. So now, what is a byte? A byte is a collection of 8 bits. So now think about 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. Here are 8 bits. And remember that the number of patterns are proportional to 2 to the power n bits. How many patterns can you get with 8 bits, with 1 byte? Of course, you get 256. 2 to the power 8 is equal to 256. So 1 byte can represent 256 patterns. The byte is very good to store characters, for example. So if you think about alphabetic characters, and if your alphabet has less than 256 characters, you can encode all the different characters of your alphabet using 1 byte. You can also represent integer numbers, which would be in the range of 0 to 255. That's a total of 256 combinations. What is an integer number? So an integer number is a number that can be written without a fractional component. 1 is an integer. 1.0 is a floating point number. This is not an integer. A signed number is a number that will account for plus or minus signs. An unsigned number is a number that can only be positive. Now, let's think about different ways to encode an integer number. So remember, if you represent the integer number with 1 byte, you will have a variation from 0 to 255. Now, if we would like to represent our integer number with not 1 byte but 4 bytes, let's compute the number of patterns we can have. So 2 to the power number of bits, 2 to the power 4 bytes times 8 bits we have in 1 byte. That makes 4 billion different patterns. So if you have an unsigned number and you use 4 bytes to represent this integer number, then this number will range from 0 to more than 4 billion. If you take into account the sign, so imagine that this number has to vary in the negative range and in the positive range, the maximum extent is divided by 2, so it will range from minus 2 billion and plus to plus 2 billion variation. Now if we would use 8 bytes to represent our integer number, same, we can compute the range of variation, 2 to the power 8 times 8, and now we come to this huge number, which is close to 2 to the power 10 to the 19. So if you use 8 bytes to represent your integer number, you can capture a very large range of integer. So it's actually important to mention that you sometimes need to be careful with the way you represent an integer number. Clearly, if you want to represent a variation which is out of the range from 0 to 255, you need to adopt another way to represent this number by using more bytes, like 4 bytes or 8 bytes. And sometimes you can run out of bytes to represent numbers, so that's something to be careful with. So the bytes are the basic unit to measure data capacity. So when you buy a hard drive, when you buy RAM, when you monitor the size of files, it's usually given in terms of bytes. And usually not only bytes, but megabytes, 10 to the power 6, or gigabytes, 10 to the power 9. So the different types, characters, integer, floating points, can be represented by different number of bytes. And as I mentioned earlier, the bits and bytes, they can be dangerous. And that's an example of what happened once on YouTube. That was quite a few years ago, back in 2012. The number of views per video were counted as integer numbers. And they were stored using a signed integer with 4 bytes. So the maximum number of clicks, the maximum possible number of clicks was 2 billion. So that was the status in 2012. And what happened is that there was this viral video, this Gangnam Style video, that went all over the planet. Everyone was clicking on this, and there was more than 2 billion people viewing the video, maybe even liking the video. And this basically led to a crash. That's what is called an integer overflow. So the number of views could not be represented anymore by using 4 bytes to represent this integer number. So be careful with integer and the representation of integers in a computer. Now, let's go to floating point numbers. So the floating point number is a number that has a fractional component. They can be represented using 4 bytes, by example. So if you take 4 bytes, this would be a total of 32 bits. So you have the blue bit here, which represents the sign. And you have the exponent, which is covering the 8 bits here, and the fractional component, which is using the 23 remainder bits here. This combination is representing the number 0.15625. So let's take the example of the number pi. Pi would require ideally an infinite precision. It's 3.141592 blah 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 blah. If you code pi in a single precision, you will cut off the precision naturally. You will limit the number of decimal digits to 6. So in single precision, you will lose the information which is there. So the number will be strictly correct only up to the 6th decimal digit. So this is for the case of a single precision floating point number. Another type, which we will use, is the double precision floating point number. In double precision, 64 bits will be used. So that's the equivalent of 8 bytes. Again, 1 bit for the sign, 11 bits for the exponent, and 52 bits for the fraction. So in double precision, the number pi becomes this one. And you see that you gain basically 15th decimal digit. So you increase the precision of your number quite dramatically by using double precision. So to summarize what we discussed today, we have overviewed how information is encoded in the computer. Basically, the information is encoded using bits and bytes. Bytes are collections of 8 bits. Remember, the bit is basically a logical state that varies between 0 and 1. So 1 bit will have 2 patterns. And the more bits you will use, the larger the number of patterns you can represent. Using this, one can code up the basic data types, such as characters, integer numbers, and floating point numbers. So during these two first lectures, we discussed the internal structure of the computer and the way the data is encoded. But now we will need to discuss how you will interact with the computer. You're sitting both at the input side and the output side, and to pass on information to the computer, we will need to discuss computing languages. That's what we do in the third mini lecture. Thanks for your attention.